All right, we are still technically in section 6.1. This is 6.1c. We are going to talk about quotient of powers, negative exponents, and zero powers. So we've got 3 more rules to talk about today. I'm guessing we're probably ready after all the time it took me to get the iPad squared away. Anybody need more time with their objective up there? Okay. First up, we've got the rules of exponents for quotients of powers. For all positive integers, m and n, a to the m power divided by a to the n power is equal to a to the m minus n power. To divide powers having the same base, you subtract the exponents. Okay, when we multiplied the same base, we added the exponents. If we are dividing the same base, we subtract the exponents. The rules for exponents of negative powers tends to be one of the most challenging rules for some students. The general rule is a raised to the negative n power is equal to 1 over a to the positive n power. So negative exponents are reciprocals. Which means we'll have fractions involved on a lot of these problems. Negative exponents do not make a problem negative. So it doesn't mean that the number or the variable itself is negative. The a here is never a negative in this case. Only the exponent was a negative. We'll talk more about that when we get to our examples. On the same slide as that is our rules of exponents for zero powers. Anything to the 0 power equals 1. The number 1. So you could just put a big number 1 right there. So that means a to the 0 power equals 1. Or 2 to the 0 power equals 1. If you have a bunch of stuff in parentheses raised to a 0 power, the whole thing equals 1. That's probably the easiest rule as long as you memorize it. Anything to the 0 power equals 1. Need more time on this slide? Okay, let's get started with some examples. On example 1, we are dividing the same base. What's the base? X. We're dividing the same base. So what are we going to do with the exponents? Subtract them. So we would have x raised to the 6 minus 2 power. That gives us x to the 4th. That's all there is to it. On number 2, we have a 0 exponent. What does that 0 exponent belong to? The y. Does it belong to anything else? No. So the 13x would stay the same. Y to the 0 becomes 1. The whole thing becomes a 1. 13x times 1 is 13x. Now that's a little different from number 3. On number 3, that 0 exponent belongs to what? All of it. So you could, if you wanted or needed to, give the 0 exponent to everything. That's a rule that we'd already talked about. 0 to the first power is 1 times x to the first power, or the 0 power is 1 times y to the 0 power is 1 times 1 times 1 is 1. So in the future, I don't need you to show me all of this. You should be able to know that anything, including that whole big set of parentheses raised to a 0 power, is just equal to 1. This kind of shows why it works out that way. Questions, concerns on our first few examples? Need more time. All right, if we flip over, we've got a few more. So 2 to the negative 4th power. Now we've got those negative exponents. That means that we have to use the reciprocal. So we are going to have 1 over 2. When we make the reciprocal, the exponent becomes positive. So 1 over 2 to the 4th. But we can evaluate that because 2 to the 4th is equal to what? Close. 16. So this really is 1 over 16. Yes.
If you just solve it and you already know how to just put the 1 on top, can we just straight go to the second one?
On number 4? Yes, that's fine. If you go straight to the answer, that's fine. Today I'll probably show a lot of the intermediate steps since for many people this is the first time they've seen it. All right, on number 5, we have a base. What's our base? -3 raised to a negative exponent. So this means we're going to have 1 over. -3 is still our base. The base sign didn't change at the moment. But our exponent sign is going to change to become positive when we move it. Okay, so this becomes 1 over. Now, -3 squared is going to be what? Positive 9. Okay, we end up with a negative times a negative, or a negative raised to an even power, so our answer is positive. All right, on number 6, what we have right now does not have any negative exponents. We are dividing the same base, so what are we doing with the exponents? Subtracting them. So we keep the same base. We take the top exponent minus the bottom exponent every time. So 5 minus 2 gives me y to the 3rd. Do I need to make this into a fraction? No, because the exponent is already positive. Questions about that? Okay, so the note at the bottom, it's not my favorite, but we can fill it in. Negative exponents repeat multiplication of a quotient. Or of a fraction. So 2 to the negative 4th power is really like 1/2 times 1/2 times 1/2 times 1/2. Okay, so instead of it being 2 times 2 times 2 times 2, 2 times 2, yes, it's 1/2 times 1/2 times 1/2 times 1/2, which still gives us the same thing here. So usually you won't see it written out as repeated multiplication of a fraction, but that is another way of thinking about it. So 3 to the negative 2nd power is like 1 over -3 times 1 over -3, which again would still give us 1 over 9. It's just a different way of looking at the problem. Questions, concerns before we do some more? Okay, usually these rules on their own aren't so bad. It's when we start mixing them in with other problems or other types of rules that it gets a little confusing. So we'll just take it one at a time. Number 7 does end up using 2 of our rules. So we have a negative exponent, but we also have a power raised to another power. That's a rule that we got quizzed on yesterday. If you take a power and raise it to another power, what do you do with your exponents? Multiply them. Okay, power to a power or exponent to an exponent, we multiply. So we can still apply that rule. We would end up with z to the 4 times negative 3. 4 times negative 3 is negative 12. But we are never going to leave our answers with negative exponents. So now to get rid of the negative exponent, we have to use a fraction. So this ends up being 1 over z to the 12th, positive 12th power. Questions about that? No questions? Okay. Number 8. We are now dividing the same base, or same bases. When we divide the same base, what do we do with the exponents? Subtract them. So you have to do one base at a time. So the first base is what?
5 minus 2 is 2.
The first base
G.
is g. So we take the top exponent minus the bottom exponent. 5 minus 2 is 3. So we end up with g to the 3rd power. Our second base is h. What are we subtracting? 8 minus 1. Very good. So we have to remember that if there's not an exponent written there, it has an exponent of 1. So 8 minus 1 is 7. So h to the 7th. Do we need to turn this into a fraction? No, none of our exponents are negative. We can just leave it alone. Okay. Problems like number 9 are going to introduce us to something a little bit different. Number 9 can also be done multiple ways. Okay, one way of doing it is to deal with the negative exponent first. The other way of dealing with it is to get rid of the parentheses first. Okay, I'll show you both ways, and you can decide which one you like better. So the first way of doing it would be to get rid of the negative exponent first. Now, earlier on in the notes, we mentioned that negative exponents give us reciprocals. So far, we haven't had things as fractions already, so we've had to put them under a 1 because it kind of starts out over a 1. But if we already have a fraction, we should know how to take the reciprocal of that. What do? How do you find the reciprocal of a fraction? You flip it. So, if I want to take the reciprocal of y over 3, what would it be? 3 over y. If you take the reciprocal, it's going to make your exponent positive. So this is one way of doing it. If it's already a fraction, you can go ahead and flip it, and then it makes your exponent positive. Now, another rule that we haven't talked about in depth yet is the fact that we have a quotient or a fraction being raised to the 2nd power. This is kind of like when we have a product raised to a power. The power belongs to everything inside those parentheses. So the power belongs to the 3 and to the y. Does that make sense? Power outside parentheses belongs to everything inside. And 3 squared is 9 over y squared. So that's one way of doing that problem. Do you have questions about that way of doing it? Okay, I'll switch colors. You don't necessarily have to write down the second way to do it. If you want to, you can. The other way of doing it basically puts the steps in the other order. Meaning I'm going to give this exponent, -2, to everything inside the parentheses. So y gets a -2 power, 3 gets a -2 power. In order to make the exponents positive, you have to flip where the things are. Meaning, to make this exponent positive on the y, the whole thing has to go down to the denominator. In order to make this exponent positive on the 3, it has to come up to the numerator. So to get an exponent to switch from being negative to being positive, you just have to switch what side of the fraction line it's on. So we switch 3 to come up top, y to go on bottom, and again, now we're at the same place, we get the same answer. So we would equal the same thing either way. It does not matter to me which way makes more sense to you. That's the way you should stick with. They are both equally correct. Do we have questions about number 9? Okay. Number 10. Again, there are multiple correct ways of doing this, but I definitely think there's one way that's easier than the other ways. We have an exponent raised to another exponent. If you have a power raised to a power, what do you do with those? Multiply them. So -2 times -1 is +2. So now we don't even have to deal with any fractions. The negatives canceled each other out this time, so we don't have to even worry about it. 6 squared is 36. So here is where I'll point out one of the notes that we had about negative exponents. Negative exponents don't make your answer negative. So we had negative exponents up here. That had nothing to do with whether the 6 was negative or whether the 36 was negative. So don't get your negatives confused with your base. A negative exponent doesn't mean your base is negative. Number 11 brings back another old rule of ours. If we're multiplying the same base, what do we do with the exponents? Add them. So this time we have 7. What numbers are we adding? Good. 4 plus -6. What is 4 plus -6? -2. We all okay with that part? We are never going to leave negative exponents in our answers. Anybody know what I should do next? Lydia? Good. 1 over 7 to the second power, or 7 squared. And 1 over 7 squared is going to equal 1 over what? Close. 49. Good. Questions, concerns? I know we're going through these kind of slow, but I want to make sure that we're all understanding as we go. We got a lot of rules to remember now. All right, number 12. We are multiplying the same base. So what are we doing with those exponents? Adding them. If we add 100 with -100, what do we get? 0. We have x to the 0 power, which really equals 1. Anybody need more time on that slide? Okay. On we go. On number 13, what does that exponent of 3 belong to?
All of it?
Everything inside. So 2 is going to get cubed, or to the third power. X is going to get cubed, and 5 is going to get cubed. Okay, so just like before, if there is an exponent outside of parentheses, it belongs to everything inside, even if it's a fraction, top and bottom. Okay, 2 cubed is 8. X cubed stays the same. 5 cubed is 125. Number 14 is similar to one of the other problems we did earlier. What was that? Number 9, where I showed you 2 different ways of doing it. I prefer the first way because I like to make my exponent positive as quickly as I can. So one way of making your exponent positive when you already have a fraction is to do what to it? Flip it, or take its reciprocal. So right away, we could flip the fraction 4 over 3c, and that makes our exponent positive. Now, everything in those parentheses gets what power? 2. Power of 2 squared, second power. So the 4 gets squared, the 3 gets squared, the c gets squared. 4 squared is 3 squared, and c squared. There is another way of doing that problem. You could give the -2 to everything as a power, and then you could rearrange everything. In my opinion, it's easier to make your exponent positive as soon as you can. On number 15. This is actually like a problem we would have done on your quiz. What's happening? Okay, everything gets the third power. So -3 gets a third power, and x gets a third power. Be a little careful on this part. -3 to the third power. -27. Okay, so remember this is -3 times -3 times -3. Because the negative was inside the parentheses with the 3. Questions about -27x cubed? Are we sure? No questions, concerns, or confusion at this time? Okay.